So first thing, we're going to talk about statistics and probability. We will spend a little bit time on probability, not a lot, because usually students don't quite like probability, right? It's about counting principle and counting technique, and problem can be very complicated. Now, what we're going to focus will be the basic, very fundamental concept of probability. It was because the probability is actually the backbone of statistics. All the influential statistical procedure are developed based on some probability concept or probability model. Okay, you will see later on when we get to those chapters. Okay. So what we want to know first is actually we're going to focus on statistics more, and we will mention probability in a little bit. What is statistics then? If I ask you what is statistics, what will you think about? What's the first thing coming to your mind? Well, you will probably think about numbers, okay, charts. Okay. Every day, in your life, you probably would involve in some kind of statistic, or you need to use some kind of statistic. You went shopping, you would do some statistic manually, right? Try to compare prices, where, right, or what price is better price, and you can buy from it. Okay, even just driving to school, you probably would do some statistic, right? You go different routes, right, and which route will have higher traffic, maybe shorter, maybe have higher traffic or less traffic. So which route will get you faster to school? Okay, you got to have some statistics on traffic, and also, of course, you need to know the distance from for taking different route from your home to school. I do that actually. And taking left lane or right lane, I kind of mentally did some statistics, right? At some section, I probably should stay in the left lane. Some section, I should stay in the right lane. So I'll be able to pass through the traffic faster, especially, I think, on that Mahoning Avenue. That's kind of weird, right? But I did that. So it's very useful. In fact, you're using it every day, but you don't know it, okay? A lot of time when I ask people about statistics or introduce to people that I'm a statistician, people will say, wow, you're the guy who's always telling lies. You're the guy who's always playing black magic, right? That fool people. Well, actually, because of the misuse of statistics, a lot of times people have wrong impression about statistics. Actually, it's very important, right? Launching a shuttle, you need to do a lot of statistics to be able to, make a successful launch. Okay, investment, a lot of things, right? Even medical procedures. You want to do some statistics to evaluate the medical procedure to see which one is a better approach. Okay, it is sometimes that you misunderstood the statistic probably, and you made the wrong decision. Right? What is statistic for? It's actually you're collecting information. A lot of times it's number, right? And hopefully you can use that to help you to make decision. But sometimes you may misread information. I have a friend one time, years ago. She went to a doctor. She was high age, but she was pregnant. So doctors recommend her to do amniocentesis, right? Put a needle into your body and then take some liquid out and checking whether your baby is in good shape or not. And the physician gives him a form, consent form. Usually that will happen. And there's a statistic there. The failure rate is 1 out of 200. Okay? And you read that, what will you think? Will you take the risk? 1 out of 200 seems like it's very small. Okay? But you have to be careful. There are so many other factors that might be in. That 1 out of 200 is what? It's kind of a general statistic. It's probably using all the physicians or all the physicians who have performed this procedure, right? And counting the percentage of success, the successful rate. And my friend, she went to the procedure and she failed. 1 out of 200, that's really small, right? She failed. And she then realized that this physician just started practicing that procedure, okay? So the statistic from this kind of person may not be 1 out of 200, maybe 1 out of 10, okay? So you got to have some good enough knowledge about certain issue to make your decision. You don't want to just look at a number, right? My friend may want to say, wow, you lied to me, right? How come I just so unsuccessful? And plus, all the patients that have gone through you wasn't so successful? Well, because you probably misread this. After a few years, when this physician have more experience, this physician may approach or get closer to that rate. Okay, so you have to be careful. Every time you read a number, they're really good information, but you want to make a good judgment. Okay, so it is crucial, right, to understand what you're reading. So a lot of people say statistics is lie and nothing but lies. Then I will have no job because what I do mostly a lot of time is statistics and using statistics to help people make decisions, to help people to understand what's going on currently, right? Maybe in political situation or maybe economic situation and all kinds of things, right? Statistics is really important. But if you misread it, sometimes disaster will happen. So you have to be careful, right, when you read statistics. Hopefully, that's one important thing that you won't forget from this course, right? It's a basic idea, but it's really important. So in fact, statistics is not lies. It depends on how you look at it. It's actually, people gather a lot of good methodology, scientific methods, right, for understanding problem, and hopefully it'll help you to solve problems. That's what statistics is, okay? But again, if you misunderstood a number or didn't pay attention or read carefully about a number, then you make wrong decision. Okay, so that's really important. Okay. Why do we need statistics? I hope those notes are pretty close to this. This is somewhat extracted from the PowerPoint. Okay, so why do we need statistics then? Well, because everything's so different. Okay, weather is different every day. You have a manufacturer that manufacture this table. Supposedly it's of certain dimension, but every table will be different. Okay, size-wise, maybe less than half an inch or tenths of an inch different, but it's different. Because of that slight difference, the quality of each of these desks will be different. Okay, we're all human beings, and in this class, most of you are female. Being female, that doesn't mean that you're all the same, right? You're so much different. But if you want to just understand certain characteristics of female, it'll be different. And how do we really can get a better understanding of that? Statistics, right? You use statistics for understanding the variability between subjects that involve in a certain problem you like to solve for. Okay, so that variability actually is one major thing that we want statistics. We need statistics for. Right? We will learn some statistical technique to help us to understand actually all the subjects that we're going to talk about later on about statistics. Will be all about studying variability. And we will learn certain statistical measure or graphing technique to help us to understand this variability. Okay. Of course, also the uncertainty. As I say, we never know what's going to happen tomorrow. Weather-wise, or maybe economy. Okay. And how do we do that? People will gather information and try to use some statistical technique to help us do the prediction. How did these meteorologists figure out the temperature roughly at what range? Right? They gather a lot of statistics, right? And nowadays using very sophisticated computing technique, right? Machine to help them to finalize their prediction and get some number. These are all statistics. So because of the existence of these two major issues, we need statistics to help us to solve problems and help us to actually make a correct decision. So what is statistics then? Well, this is a kind of a brief, short definition of statistics, right? Based on that we really need statistics to understand variability and uncertainty. This is one way we define statistics. Statistics is a science of understanding data and making decisions in the face of variability and uncertainty. Right. That's actually a general definition of statistic. By the way, if I give you a test question, right, I won't ask you to state the definition. Right? If there's a definition kind of thing, it'll be through some problems, okay, or multiple choice. Right? You don't have to memorize, but you really like to know the idea behind all these definitions. Right? Now this is something that you saw daily, some kind of statistic. This is a frequency distribution. Okay, you have population for different area in California and the number of cases of pneumonia. Okay, and this is the statistic presented in terms of frequency of counts, and you saw that all the time in newspaper. Okay, people can use these frequency to determine, well, in what area we have more serious problem. Okay, what will you do then? Now, by looking at this, which area has the more serious problem? Los Angeles, right? Look at it population-wise in this different area. It's about the same, but the frequency in Los Angeles is higher. Okay, this is the kind of statistic that you can read and understand very quickly. Okay, but usually, when you saw these report, you also like to know how they gather these information. It'll help you. Okay, don't be fooled by just a number. Sometimes there's something behind a number, right? How do they gather these information really affect how you interpret these numbers? Okay, if I say these are really the whole population there, right? Really just the whole population. These are really the counts. We get all the cases that reported to us, right? This is all the cases reported to us. So you're going to interpret in this way, all the cases reported to us. There is some cases probably non-reported. Okay, it could be that in Sacramento, the majority of them are not reported. Okay, now if you read this, you'll have a wrong idea. Okay, so when you read statistics, don't just look at a number. You want to understand the background a little bit, especially how they gather the data. That's very important. Usually in any statistical project, data gathering, right, data collection takes most of the time, maybe 80% of the time. And then the number crunching and organizing the data take less amount of time. Right? Defining problem, gather data take longer time. And you like to know how they gather the data, so be able to properly interpret these numbers. Don't just look at those numbers only. Okay, that's really important. Now I have several slides up to this. Okay, I actually calculated percentage too. Okay, the percentage will help us to quickly, right, do that comparison. I have other pictures here. This is a picture talking about the counting number of people living with AIDS. Okay, and using these different shading, right, to help you to understand the density distribution in different areas. This is a nice chart. Right, nowadays people develop so many graphical technique, right, to display statistics, which is really nice. A lot of people can understand problems by visual, right, not by a number. Right, I think most of the people. So these graphs are great, and in fact, a lot of statisticians still developing a lot of new graphing technique to help people to understand statistics. Okay, so this is kind of statistic that you see often, right? This is a statistic. This is called side-by-side, actually cluster bar chart, which we will learn later on how to use the SPSS to make it. Okay, this chart actually tells us the percentage distribution, right, of cancer, having cancer or not, among smoker and non-smoker. Okay, and height of the bar represent the percentage. So when you look at this chart, what do you see? It's better smoking or not smoking? You see, among the smoker, you have a high percentage having cancer, right? So better non-smoking, right? A chart like this can help us understand the smoking behavior and whether you have cancer or not, which is a really nice chart. Okay, that's a statistic that you've probably seen, probably in newspaper, a lot of time in medical journal or nursing journal. Okay. And this is a statistic, again, statistical graph, right? It displays the distribution of weight among 22 subjects. This is called histogram. We will talk about that later too. Okay. And this is the kind of statistic usually you see in a journal. Okay, maybe nursing research journal. And you try to estimate the age for male and female, okay, and or systolic or diastolic pressure, blood pressure. What happened? Anybody press the button? I guess somebody probably pressed the button. Okay, it's all right. We're back. Okay. And a lot of time when you read this journal, you will see this notation, plus or minus. All right? When you see that, that usually means there is some statistical computation involved. Sometimes people calculate standard deviation. Sometimes people do so-called a confidence interval, right, for estimating certain measures, which we will talk about later too. So in the future, when you read journal paper, you see that, you understand, right? It's a piece of cake. It's not hard. Right? It's very simple. Sometimes you see those journal report statement like this, with a confidence interval written in this form, okay, or written in this form, okay. Again, like I say, we will talk about that later. A lot of times, people use different model, right, to analyze the data, but eventually they will report the result in terms of confidence interval, right? And because most of the people who have some introductory statistics would likely know what the confidence interval means. So it will be very helpful for these readers to understand the result. Okay, so we definitely will talk about confidence interval later on when we talk about statistical inference. Okay. So what is a statistic? Actually, I'm going to look at it more broad in general, actually, statistic, but specifically stated what type of statistic that we use or we study in the field of statistics. Statistics is a field of study by this definition concerning, first, data collection. Right? When you do statistics first, you have to collect some information. Right? Hopefully using them, you can achieve certain result. Okay? And generally, that's the first step. After you have your data, then what will you do? You're going to organize these information. Right? If you have a sheets of raw data, it's hard for you to understand anything. So you're going to organize them into a certain form. Maybe construct a table or make a chart to help you to understand the data further. Okay? And sometime in some descriptive study, people will just report these charts and numbers, right, to people. And a lot of scientific research will go further. Before they do these hypotheses, they have some maybe conjecture or hypothesis in mind. And they'd like to gather these information to help them to understand, right, what's happening in this data, right, so that they can use it to infer certain result or certain outcome. Okay, and that's the third step, right, or third item in this definition of statistics. That is, drawing conclusions, right, based on data that is selected from a huge population to draw a conclusion. Usually, in the statistical inference, what we will do is gather a sample from a population, right? If your goal is to understand certain population, okay, maybe the average age of female living in the Youngstown area, there's a huge population there. But let's say if I never done any census, we want to quickly get an idea. What will you do with a limited amount of time? You probably will randomly visit certain female and then try to understand, even if you try to understand the average age, you will ask these people's age, randomly select them. And that's just a small group of a population. We call it sample. Okay. What is a population? It's a collection of all the individual of our interest in the study. In this case, we're interested in female, right? If we're interested in female, then female population is what we are really interested in. And then among those female population, then you can take a random sample, which is a subgroup. Usually we like to be random sample, so the sample will be really representative. You will not just gather some of your friends and ask them, right? That will be a big bias. Okay? And then using that sample, you try to predict what's happened in the population. That's a very important part in the statistic part of this course. I believe you have learned some basic statistics, probably elementary school or middle school, right? Calculating mean and doing some bar chart, pie chart, you learn that. Those are descriptive statistics. But what we really like to learn in this, for the statistic in this course, is be able to do statistical inference. If you're taking a sample from a population, how do you use that little sample to understand the whole general population? That's the last part of this definition, and also is, I believe, is a important part for this part of for the statistics subject in this course. Okay, so I categorize the definition of this statistic into these three categories: producing data, exploring data, right, including organizing data and making charts, and then do statistical inference, right? So and usually when you do statistical analysis, that's the approach, right? That's the steps. You gather data, right, and then organize data and draw a conclusion. Of course, before that, you have a question in mind, right? You do have a question in mind. Because of that question, based on that question, you start gathering data, organizing data, and try to make some conclusion. Okay. And some people say that in area of statistics, there are these three major categories: sampling, descriptive statistics, and inferential statistics. Now, in our textbook, actually, they mention two. They say descriptive statistics and inferential statistics are the two major fields or branches in statistics. And I like to add the sampling because sampling is really important. If your data is wrong, then no matter what conclusion you draw, it will be unreliable. Okay? And actually, that's an important field of study in statistics, sampling. There are several courses that you can take if you're interested in sampling, right, about the topic of producing data. Okay? And then descriptive statistics and inferential study. Now, in our course, I'm going to just briefly talk about different sampling techniques. And we will spend more time on descriptive statistics and inferential statistics. Okay? Generally, in inferential statistics, there are also two categories in inferential statistics. One is estimation, statistical estimation. One is hypothesis testing. Okay. I get a sample of female in Youngstown and like to use that sample to estimate the average age of the whole population of female in Youngstown. That's statistical inference. Okay. And that's a estimation too. That's a part of the statistical inference. That's estimation. Now, if before you do this study, you have a conjecture, you have a hypothesis, you believe the average age for female in Youngstown is higher than 30 years old. That's average age. You have that question in mind. Then you're going to go gather the data and use that to prove this statement. You have a hypothesis there, and you want to use a sample to prove this hypothesis. That's called hypothesis testing. Okay? Does it make sense, the difference between the two? One is just estimating, right? Let's say I want to estimate the average age. That's estimation. But if you have a hypothesis, I say the average age is greater than 30. I want to test that. Okay? There's a statistical procedure that you can do to test that. Testing whether average age is greater than 30 or not, or different from 30 or not. Right? As long as you have a question, you can go through this hypothesis testing procedure to perform the test. Okay? Does it make sense? We will go into detail later on in the course. Right? This is just give you a general idea. Okay. First, I'd like to talk about producing data. That's the first thing, right? Among those three in the definition of statistics, or I say the branches are in statistics. And we're going to be brief on this, right? Although it's very important, but it will be very involved. What we would like to know is some basic idea. Okay. And even if you have taken this course, I don't really think that you can really be able to do a statistical analysis. Well, I believe some of you probably could, right? To really do a statistical analysis by yourself in the future for your organization or for your hospital or for your health department. Okay? You may not be, but probably some of you will be able to do that. Okay? Now, if that's the case, what will you do then? You will ask a statistician to help. Okay? But statistician, not really, statistician will know the term you use in your field. So you need to be able to communicate with statistician so that statistician will be able to do a good job for you. Now, in order to communicate with the statistician, you also like to know some basic terms in statistics, right? In this course, we're going to learn a lot of different terms in statistics. Okay, I'd like you to know those. Again, I won't ask you to state the definition, but I may ask you, like multiple choice, see whether you really understand the idea or not, right? Or some computation things. I won't ask you to really state the definition, but maybe ask you to calculate average, right? If you know how to calculate average, you know what's the meaning or definition of average, things like that. Okay, so we're going to go over some basic terms, right, in statistics. And these are the two terms that I just mentioned. population and sample. Okay, the population, a collection of all the individuals of interest in the statistical study. That's population. Remember, I used a Youngstown, a female in Youngstown, right? If you have a collection of everybody, all the female in Youngstown, that's a population. What is a sample? It's just a subset of this population. You don't have time to get everybody, but you would like to take a sample to understand everybody. Okay, that subgroup of this population is called sample. And the process of gathering all the data in the population, we call it census. Right? The United States doing census every few years. What they're trying to do is what? Try to reach everybody and gather everybody's information and try to understand, right, what's happening in the United States as far as the human goes, right, people goes. Okay. And if you really want to quickly get some idea of the population, but you have really very limited resource to get those, and the way you can do this is really just take a sample, okay, just a subgroup of this population to do it. And that's mostly what we will do later on. Census usually is a very hard thing to do. Even the government, if they want to do census, they cannot really get the whole population. Okay, good. Of course, data. That plays a main role in statistics, right? Without data, you can't do anything. Okay, so I think you basically understand what the meaning of data. Okay, so where do you get these data then? From individuals, right? These individuals could be human beings, could be objects, subjects, could be tables, could be pencils, could be television. Each of these is an individual in statistics. Okay. Here I define the entity on which data are collected. Okay. So the term, I think you heard that all the time. But from each individual, you can observe many different characteristics, right? Just for a human, right? You can observe weight, you can observe height, you can observe blood pressure, right? You can observe hair color, right? There's so many things, intelligence level or whatever, okay? Each of those characteristics vary from people to people, okay? In statistical study, each of these characters, we can call it variable, okay? So in some study for female, right, may be interesting in the female's age. Age itself is a variable, okay? Then height, weight, these are all called variable. But there are different type of variable though. Okay, we will talk about that. Different type of variable, we're going to analyze these variables, right, or these data using different type of techniques. Okay. So how do we categorize these different type of variables? We split them into two major categories. One is quantitative, one is qualitative. And it is important to know whether a variable is quantitative and qualitative when you try to communicate with a statistician if you hate to do the stat yourself. Okay? And because different type of variable, you tend to use different type of technique to analyze your data. Okay? What is quantitative variable? You have a variable that involves numbers, measurements. All right? These are quantitative variable. Now there are two types of quantitative variable. Discrete or continuous. Okay? Maybe I should do this. Oh, it doesn't go that far, huh? Oh, it doesn't see it. Unfortunately. Okay. Yeah, I remember this. Okay. Let's get back to this. What is discrete? What is continuous? Okay. When we talk about measure of height, weight, size of table, these are considered continuous. Any number can occur. Okay, I have a table size is 6 inches. Another table size is 7 inches, right? But there could be a table size is 6.5 inches, right? That is achievable. Okay, any possible number in the real number line can occur. This kind of variable, for a variable, this kind of variable is called continuous. Okay, otherwise it would be called discrete. Right? You have those counting number 1 and 2 and 3. Okay? These are discrete number. Between 1 and 2, there's no other counting number. These are discrete type of number. So when we talk about quantitative variable, generally these two types. Okay. Qualitative variable. What is qualitative variable? Sometimes people call it categorical variable. It is variable involve categories, labels. Okay. Like hair colors, you have brown, red. Now there are more colors, right? But they're just specific description. Okay. Gender, male and female, two categories. That's categorical variable, or sometimes we call it qualitative variable. Okay. So that's, I think, it's pretty easy to understand, right? Okay. Blood type. Is blood type qualitative or quantitative? Anybody? Qualitative, right? It's a category, right? It's qualitative. Letter grades. After this class, you're going to receive an A or B or C. Is that quantitative or qualitative? Qualitative, right? If you look at a GPA, then that's quantitative, right? GPA, any number between 0 to 4, right, can happen. Right? That's quantitative, right? That's number, right? Measurement. Okay, good. So those are, I think, pretty easy to understand, right? Also, later on, we're going to learn, or you're going to learn SPSS. In a lot of software, they have some columns or some format specifically about measurement scale. Okay, and if you have data with different measurement scale, the software may deal with it in a different way. Okay, so or you will choose a different routine, right, or statistical procedure to take care of your variable. Okay, so in terms of measurement scale. There are actually 4 different measurement scales in there. If you check on later on when you check on SPSS, you will see these different type of measurement scale in one of the format column. But anyway, these are 4 typical measurement scale that people use. This is lowest. This is highest. Lowest measurement scale is called nominal. When you have variable who are just names or labels, these are called nominal variable. Okay. If you have data that has rank involved, then this kind of data is called ordinal data. Well, among those categorical variables, just now the example I mentioned, letter grades. Letter grades is A, B, C. But you do know that A is better than B, B is better than C. So that's a variable of ordinal scale. Okay. You have blood type. Blood type is what? A, B, O, and AB, okay? Is that an ordinal or nominal? Nominal, right? Because blood type A is not better than blood type B. There's no ranking involved, okay? So that's nominal. Good, that's great. And interval, what is interval scale? What is a variable of interval scale? Generally, it's a quantitative, right, measurement. Right? That was a measurement of interval scale, right? You have a variable that is quantitative, for instance, height. Height for human probably varied from 0 in the interval from 0 to maybe, I don't know what's the limit, right? Maybe 8 inches. And in between that 2 points, every number in that interval can occur, okay? That's an data of interval scale. So I say height, that's an interval scale. Weight, interval scale. Okay. Your GPA, interval. Okay. Does it make sense? And usually they're, of course, quantitative. But I have another scale over there that is, last one, ratio scale. That's something that students usually have trouble with. What is ratio scale? In fact, when you really do data analysis, a lot of times you don't really pay attention to whether data is ratio scale or not. Okay. Usually, what is the data of ratio scale? If you have a certain reference point, 0 is a reference point, all right, then ratio of 2 numbers makes sense. In that case, this variable, right, has a ratio scale. For instance, I have this desk that is 2 feet tall. Another desk is 4 feet tall. Ratio of 4 and 2 is 2, right? This is twice as tall as this table. That ratio makes sense. That kind of variable is of ratio scale. Okay. So I guess ratio scale, it makes sense to you. What is non-ratio scale? We have all those quantitative variables. What are non-ratio scale? Well, look at the temperature. If I say today is 30 degrees, tomorrow is 15 degrees, is today twice as hot as tomorrow? No, right? That's something that we really cannot figure out. Okay? And also, when we measure the temperature, there are Fahrenheit and Celsius. In Celsius, 0 is the freezing point. Okay? And Fahrenheit at a different scale. Right? So temperature is actually a good example of data that's not ratio scale. Okay? When you have variable, the values, ratio of two values really makes sense, has a meaning. Right? That kind of variable, we can call it as a variable of ratio scale. Okay, does it make sense? Okay, but most of the time people will pay attention to whether data is nominal, ordinal, or interval. Okay, ratio usually people don't really worry that much about it. Okay. And as far as the type of analysis that people will perform, right? Notice that these are just some terminology. It would be good that you know it so you'll be able to communicate with statisticians. Or if they say something to you, it makes sense to you, okay? What is univariate? It's a term that people use often in statistics. Univariate data means what? This data only involves one variable, okay? Univariate analysis means what? In this analysis, we just look at one variable. That's univariate means. And, of course, what if we're looking at two variables? A lot of time we like to do that. We like to understand whether there's a correlation between two variables, whether there's a relation between height of human and weight of human. We know that there's a correlation, right? But if you're observing that correlation, you're studying two variables at the same time. That's a bivariate analysis. And sometimes you observe a pair of data at a time, right? And so you have two variables observed at a time. You like to have people's weight, and you also like to have people's height, and you observe these pair of data. Then you have a bivariate variable in your variables, right? You're actually interested in two characteristics. Okay. The next one is multivariate. And generally, when you do statistics, right, most of the time in research, you would deal with multivariate analysis because so many variables, they're just related to each other, right? And so when you're doing a study that you involve several variables at the same time, that's called a multivariate analysis. Sometimes you may want to see whether gender and your blood pressure would affect your GPA or not, right? Of course, I don't know whether that's true or not, whether a correlation. But you're having several variables to understand certain phenomena, okay? That's a multivariate analysis. Okay, does it make sense? Right. This is an example of univariate analysis. We only look at one variable, the distribution of weight. Okay, that's univariate. Okay, of course, we can also produce the average weight for this group. That's a univariate, but in terms of numbers. Okay, this is an example of multivariate. Actually, this chart I downloaded from American Journal of Public Health. Right, it's a chart that talks about the correlation between number of hospitalization and the minimum temperature at that time, okay, and the precipitation at that time. The horizontal axis is time, right? Different months in different years. And you see that at different times, the number of hospitalization change, right? In this area is about, let me see, that's hospitalization. It's about between January to March, right? It's the winter season, right? Of course, I guess more people are hospitalized due to flu. This is about pneumonia. And also the precipitation and the minimum temperature, right? See, there's some connection. There's a pattern, okay? This black dot is what? Precipitation, right? When it gets higher, number of pneumonia get higher. So this is kind of graphical display, right, of multivariate analysis. We actually analyze several variables at the same time. Besides those three, you also look at what? The date, right, at different time, okay? So that's a good example of multivariate analysis. Okay? And you saw this. This one, we try to understand the correlation between smoking and whether people have lung cancer or not. That's a bivariate analysis. We're observing correlation between two variables, right? That's an example of bivariate analysis. Okay. So hopefully this helps you to understand some terminology that people use. This is a graph, this statistical graph. We call it scatter plot. We will talk about it again later. We're studying the correlation between mortality index and average temperature. The average temperature get higher, and mortality index get higher, right? And this is about, I think, 22 countries, right, in Europe. And you will see that's very strange, okay? How could that happen? Well, you got to understand a little bit more about background of these data, right, to be able to really understand this data. You don't want to conclude that right away. Say, well, I don't want to live in low temperature area, right? A lot of times, because what, these low temperature area and this country in low temperature, right, they are underdeveloped. Those countries in cooler temperature, right, they're more well developed, so they have better health facility, right, and that, or maybe health education too. So that will reduce the rate. Okay, that could be the reason. Okay, but again, this chart kind of shows you the correlation between these two things, temperature and the mortality index, and which is a nice chart. And usually, when you're doing these statistical analysis, you have a problem there. Maybe you find out, well, why there's so many people got cancer? Okay, and so cancer is kind of like an outcome. A lot of times we'll call this variable an outcome variable. Okay, so that's the terminology that people use, outcome variable. Sometimes people call it response variable. It's an outcome in response to certain situation or certain behavior. Sometimes we call it dependent variable, because whether you will have cancer or not, depending on whether you have such a behavior or not, right? So these having cancer or not, we can call it as a response or dependent or outcome variable. And the causes or possible reason, like whether you smoke or not, that could be a reason, okay? We call that explanatory variable, because of whether you smoke or not, right? That'll explain whether you get cancer or not, okay? Or whether age is a variable, is a factor, right? Is the age affecting whether you get maybe colon cancer, right? The older you get, probably you have a higher risk to get colon cancer, okay? So we think that, well, age is probably the reason that people, right, higher age or maybe a factor, a risk factor. The higher the age is, the more likely you will get the colon cancer. And so this age becomes, again, what? Some variable that you can use to explain why we have those outcomes. So we call the age the explanatory variable. Okay? Does it make sense? Right? These are the terms that sometimes you need to communicate with a statistician. Right? Or when you're doing your own research, you need to be able to identify them so we can pick the proper procedure to help you to do the analysis. Okay? Does it make sense? Okay? And you haven't seen anything that is very hard, right? Okay? And during the course, probably will all be like that. Again, like I said, the math, right, requirement for this is very low, but you like to understand the concept, right? A lot of statistical concept you need to know in order to really understand the data better.